Imagine you're peering through a tiny keyhole into a locked room. From this highly limited angle, you can see exactly one thing: a single dog sitting on the floor. If that narrow glimpse is the only information you have, you'd have every reason to conclude the whole space is just a home for dogs. But when the door finally swings open, you realize you're actually standing in a busy veterinary clinic, surrounded by cats, birds, and lizards. By looking only through that tiny opening, you missed the real story. Machine learning algorithms, the computer programs that help decide who gets a bank loan or whose resume is good enough for a job, operate exactly like that keyhole. We often think of computers as perfectly neutral, but they don't have their own eyes. Their entire world is built out of the specific piles of data we choose to give them. If our data has blind spots or old prejudices, the algorithm doesn't fix them. It treats those flaws as absolute rules, making them even more powerful than they were before. Let's see how this works in the real world. Imagine a company building an AI program to automatically sort through thousands of job applications to find the perfect new hire. To teach the AI what success looks like, the company feeds it records of their best past employees. On this map, successful employees appear as green dots. But there's a problem. Most lived in the wealthy neighborhood right next to the office. Because data came from one spot, the computer missed the rest of the city. This is what's known as selection bias. It's like trying to understand a whole forest while only ever looking at one single tree. The information is real, but it doesn't represent the big picture. The AI doesn't know it's missing anything. It simply assumes that living in that one specific neighborhood is what makes someone a great worker. Now, the algorithm automatically rejects brilliant candidates from across the city simply because they don't live inside the narrow keyhole the computer was shown. It's not just the data that can be skewed, it's also the humans who set the computer's goals. Think about a manager with a master's degree who is training a hiring AI. Subconsciously, they might tell the system to prioritize candidates who have that same degree. The manager is working on an assumption that anyone without that specific title isn't qualified, even if those people have years of incredible hands-on experience. This is a form of group attribution bias. It's that human habit of judging an entire group of people based on one narrow trait, especially when we aren't part of that group ourselves. The AI isn't actually being objective. It's acting as a high-speed mirror, reflecting and enforcing one manager's personal stereotypes on a massive scale. Sometimes, these errors come from everyday experiences that we don't even realize we're carrying with us. This creates implicit bias. It's like a mental autopilot, where we act on old cultural assumptions without even noticing it. For instance, a North American engineer might program an AI to flag the color red as a sign of danger or aggression, because that's what red means on their local stop signs and warning lights. But look at the difference a culture makes. For an applicant from China, that same red represents luck and joy. To their eyes, a red portfolio is a celebration, not a warning. Without any bad intentions, a developer's personal background has turned the AI into an unfair gatekeeper that penalizes people for their cultural differences. So what happens when a team views the biased, unfair list of candidates this AI produces? There's a very common urge to assume the computer's list must be right just because a machine did the math. This is automation bias, that strange instinct to trust a digital result more than our own eyes and common sense. To fix this, we must break that cycle of trust and reject the computer's answer when it doesn't match the real world. Creating a fair algorithm requires us to go beyond the math and take a hard look at where our information is actually coming from. Before we ever let a model make a real decision, we have to do the work of finding and removing our own human biases from the code. To build technology that truly works for everyone, we have to stop peering through the narrow keyhole of biased data and finally open the door to the full picture.